Okay, staying with this roof plane, we're going to add some roof windows. The grey that you see on the screen is rather difficult to see, so I'm going to work on layer roof setout. Okay, now I want you to draw a rectangle starting in this bottom corner. So rec, return, that's your start point. Turn your O-snaps off, and then relative to that start point we want to go at 900 wide, 1800 high. Now if we restore the plan now, we can decide where we want to put some roof windows. So type plan and return twice, and this is just done roughly. I pick the object, return. Base point can be anywhere, the O-snaps are turned off, and I'm just moving the roof light up onto this portion of the roof, and I'm going to copy some of those, put ortho back on, so I'll have another one there, and I'll have another one the same distance apart. So use my object snaps to help me do that. There we go, 3 roof light positions. Twist over, you'll see that they are in the plane of the roof. They haven't dipped or dropped down onto the floor. If you're at all dubious of that, use the distance command from corner of grey to corner of green. There should be no change in the Z coordinate. Delta Z is 0. These are nasty numbers because I just did it in a random kind of position. Okay. Now what we'll do is bring in some roof windows. These are already drawn, modelled in a very similar fashion. So I want to just check my notes, and I realise that I need to extrude these by the depth of the roof before I can bring in the roof light block. But how thick do I need to make that? Now I can use the screen to help me. I'm in the roof plane UCS, so if I drew a polyline from this corner to this corner, it's going to give me the height, the thickness of the roof overall. So PL, return, from corner to corner. See the way the O-snap icon is dislocated? Press return. If you don't believe what's happening here, do a distance from this position to this one. There will be no change in X and Y, but the Z will be the thickness of the roof. Delta X 0, delta Y 0, delta Z minus 400. So we've established our roof thickness. Let's see if we can get the software to give us the extrusion without typing in numbers. So ext return, pick the 3 shapes, return. I want to extrude from that position to that position. It's gone upwards. That's okay, we can move them down in relation to themselves. So M, return, pick, 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 return, position on object. Tricky. I'll have to try that a different way. So M, return, 1, 2, 3, return. Take the bottom corner of the object, place it on the end of the polyline. Delete the polyline, it's done its job. Now we're going to be taking this shape out of 2 layers of solid. Now we can't use one shape to cut through 2 objects. We have to have duplicates of these, so additional pastry cutters if you like, to deal with the 2 layers. So we're going to copy them onto their selves. CP, return, pick, 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 return, base point, pretend to move away, come back to the same point and select. Then press return. Seems a bit complicated, but we've got 2 here, 2 here, and 2 here now. If you don't believe me, erase, pretend to erase, 6 found. 3 times 2. Okay, now you can have a bit of fun subtracting. Subtract from the grey object, return, pick each one of these once, very carefully, don't use crossing windows, then press return. Okay, subtract again, go for the white object this time, return, pick carefully the green objects and return. If we do a shade now, we should see through a hole in the roof. Perfect. And now we can bring in our roof lights. So insert, block. We want to use a roof window. Click OK. And the insertion point for the roof window is at the back corner at the bottom of the cutout. Select it and return. Do that another 2 times. These roof windows have been modelled with the windows actually open. Can give a wee bit of life to a scene if you show 1 or 2 windows or doors open. Right, we need now to deal with the main windows. Okay, we're moving on to Windows now. Now I'm just going to open another file. I'll call it, let's see, this 3D faced window. This is the block that we're going to use in our scene. Now this is what I would term a kind of typical window. The golden colour here, that's the wall returning in. Usually in Scotland that's 100mm or 125mm. It's called the reveal. We've then got this green object here. This is your window frame. There's a pale blue 3D face in there. That's the glass. And then you need a wall on the inside as well to fill the hole on the inside of the wall. So we've got an internal wall reveal. I've also modelled in, using 3D faces, a simple sill. I'll show you this from the front. We've got surrounds, frame, glass, and grey sill. If I shade that. View that from the side. Now, it's horizontal on the floor at the moment. It's kind of been laying down on the ground. But you can see that the window reveals, internal window reveal will be higher up than the external. That's to allow for the window sill. But creating it from 3D faces allows you to maybe modify the height of the sill. Could add another 100mm onto the sill. It's much easier to tweak kind of fairly complicated objects like windows if they're made out of 3D faces. Okay, your sills might extend outside the window. If I open another file to show you, here we've got a few more different versions of windows. That's kind of the one we're using there, but it's actually got a secondary frame. Main frame, and then secondary frame is the bit that actually opens. So you can see here, this is the opening, called the opening light, and this is a dead light. Over here, we've got a central bit of frame in the middle. The window has to have that to keep it watertight. This window's also got a sub-sill. It's part of the actual window frame. The window sills here extend outside. I'm just going to twist this over. I think the UCS is set to something. If I twist a wee bit more, there we go. then shade it. What I've placed here is a node in the standard window that allows me to use it as a reference point for the walling around the window. So putting a wee bit of attention into your standard window designs can make your model very, very rich indeed. Let's close these two, get back to ours. Now we have a window available for us to use, the 3D faced window. It's ready to bring into the scene. But I don't want to bring it in this UCS. I need to be back into one of the side UCSs. So let's go for the front one first. Let's do the front window. Then insert, block, 3D faced win. Click OK. Right, the control point for this window seems a bit random, so I'm just going to drop it in, press return, and then move it into position. So M, return, pick the window, return. Base point is the end point there, and I'm going to stick it into the window opening there. So if I shade it, you'll see we've got some problems to deal with already. The window isn't wide enough to fill the window opening, and it's too high. It needs to be shrunk. So before I do that, I'm just going to copy that back out to here. And I'm going to make just have a copy there that's unadulterated. And I'll explode both of them. So X, return. Pick both those windows and return. Right, when we adjust this window frame, we don't want to accidentally pick up any of the walls. So I could lock layer Xed wall. My mistake. I made it current as well. Roof setout was current. Roof setout can be left as the current layer because it's kind of nice and bright and colourful. Okay, give yourself the front view now. So plan and return twice. Now, what I'm going to show you now is how you use polylines to help you extend and trim and manipulate other objects. Now, I need this window to be widened from this position to this one. I don't necessarily have to know a dimension there. I can draw a polyline over the top of that. Now, polylines do not vary their Z coordinates, so the line that I draw will be true. It will be straight from that position to there. No deviating backwards or forwards in 3D space. So PL, return, from endpoint to endpoint, return. Now move that polyline out of the way. Just let it sit in free space. Do the same down at this bottom corner of the window. PL, return, let your O-snaps find an endpoint, to endpoint, and return. You have to be careful that you don't pick ambiguously. So we move, so pick the object, return, and move it out of the way. Now we move it out of the way so that there's no chance of me accidentally picking the wrong endpoint. If I left it where it was, very dangerous. Now, layer Xed wall should be locked so we don't accidentally move any of these positions. Then you should use the stretch command. So it's quite a difficult command to use. So S, return. You must select by a crossing window or a crossing polygon. And what that means is when you do your selection of the vertices that you want to adjust, you do it using a crossing window. So I need to adjust all those positions. Press return. Base point, destination point. So moving it relative to that object. We'll then stretch again, so it's S, return. Capture the edge of the window completely and return. Base point, destination point. Absolutely exact. No little gaps here and there. Let's rotate and show you that. It's a big long window. I think we'll change to the setout layer generally. So what we need to do now is draw a rectangle over the inner window face. Now this wall eventually is going to be 300 millimeters thick. That's a bit thin nowadays with the insulation requirements. You're probably nearer 400, 450. But we'll just run with this 300. If I needed it thicker, I could look down on the building in plan and stretch that window inwards in a similar fashion. So let's draw a rectangle from corner to corner. Notice the way the O-snaps or icons lurked out here, even though the correct position was back in there. That's fine. So that window is ready to use. While we're in this UCS, let's draw a rectangle over this window. And using the stretch command, make it by eye. You need ortho on for this. I'm making it by eye a lot thinner and a lot shorter. Now what I'll do is move that window into this position. Move, return, pick the window, return. You're looking for a common point. So end point there to end point there. Thinking 3D as you're doing this. I can't rotate the window back into the wall using this UCS. I need to flip it round by 90 degrees. So we'd need to change back to the world coordinate system and then rotate the window. RO, return, capture the window, return. Base point is that common point that you chose for the move. Click and drag. Now from this angle, we could either do this using polylines or just try and do it by eye. Should be okay. So S, return, capture this. Remember, external wall is locked. Press return, base point, destination point. And for some reason it didn't take the rectangle. Why not? Maybe I missed out selecting it. I'll try that again. Hopefully a set out isn't locked. Is it on the right layer? Yeah. So S, return, capture everything, return, base point, destination point. Now I'm a bit baffled here. I'm going to list that object. It's a polyline. Yeah. Okay. Now it shouldn't be defeating us like that. I'm just using grips instead to stretch that. Let's see if it does it. It may be because of the UCS. Let's try changing the UCS around to the left UCS and then try a stretch. Select everything in the bottom of the window, return. Be careful now, you need to select the correct base and destination point. So it's end point here to end point here. Yeah, it's let me stretch that rectangle this time. I think it was because I wasn't in any of the kind of side UCSs. It was resisting. Okay, we want to copy that window. CP, return. Pick the window, return, and base point to destination point. While you've still got control of it, drop a copy over on one of these windows. And then we can rotate it inwards if we change to the world UCS. So RO, return. You do need to pick this individually. You can't use previous or anything. You have common base point and get the rotation correct. Should come in the way. And then CP, return, P for previous, return, and you're looking for the common point, base point, destination, 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 return. Now once you're fairly confident with the UCSs, then you don't necessarily have to go back to plan or side view each time. You can work where it's at. The corner window is a bit trickier. We can start off using a copy of this window, but it will need extended and we'll need to deal with the 90-degree bend. Now this method will work with any window that you encounter that has kind of facets in it. So let's go for it. So we'll need a copy of the window first. So CP, return, put a window around the window, sorry about that, base point, and destination point, let's escape that, let's try that again. I picked the wrong base point. We need to pick a base point at the top of the window. I think we'll turn off the roof layers just to give us a bit of respite from those. So the base point is going to be the top corner here, actually. So CP, return, put a window around the window, and return. Base point to destination point, and return. We need to rotate that round. So RO, return, capture it, return, base point, angle. And what we need to do is erase these objects. E, return, capture the corner with a window, and return. What we'll now be doing is looking downwards. So plan, return twice. The first thing you've got to do is establish the angle up here. I know it's going to be 45 degrees, but let's say it isn't. You can trace over the top of this. So PL, return. I've got my nearest object snap on, so I can go from here to here to here. Now, all three positions on my polyline are at equal height. They haven't dropped at all. I can then offset by any amount and then draw a polyline from corner to corner and return. That's exactly the dividing line of that angle. It subtends it. Pick the two polylines and delete them. I need this line extended a bit, so I'm going to draw a circle on top of it, reasonably big, and then extend out to the circle. There is a lengthen command in the new version of AutoCAD which is reasonably useful. Alright, now this is the crux of this one. How do you extend these by different lengths? Because this corner only has to go to there, whereas this corner has to go much further. And this is where the polylines come in handy again. So we draw polylines up right the way through. Then trim off the ends. TR, return. Pick your cutter, which is that polyline, and return. And it can chop these off. These might not be touching each other in 3D space at all. If I rotate, you see there's daylight between them. But when viewed straight down, the command still functions properly. We then need to move these out the way to use as reference lines, just like we did when we stretched the window. So it's the stretch command again. I'm just going to delete that red line there. So S, return. Very carefully capture just one corner at a time. and use its relevant reference line. This one's a wee bit trickier. These lines have done their job, delete them. Now still 3 more to do. There's 3 lines to be brought up from here. Didn't want to do them all in one go because it just gets a wee bit difficult to see what's going on. So in exactly the same way, we do the trimming, so tr, return, pick, return, chop, chop, chop. Then move the red lines out the way, and then you can use them. So stretch again. Turn your O snaps off if you need to create your crossing window. Sometimes it can be a bit tricky. Extending the glass out to the corner, and the last vertex. Delete those lines. This line can be deleted as well. Fits perfect. Let's rotate that. Just make sure you've not accidentally messed things up. And you can see now the shape. Everything's happening on this 45-degree cut. Go back to the plan again, and because the yellow layer is locked, we can safely mirror this object using any vertex along here to help us with the mirror line. So we'll do that. So mi, return, put a window around everything there, return. Set up your base, your mirror line, vertex to vertex. You don't want to delete the source object, so you press return. Seems laborious, but it's actually an extremely accurate way of creating a clean corner window in that fashion. You know, it's an architectural feature that's quite common nowadays. I'm going to turn things around, and what I'm going to do is take a window opening and use it to create a door. So we'll copy one of the windows and use it as a door.